Hey everybody, welcome to my AB200 presentation on the physics of stringed instruments. Since the days of the cavemen, we have been making sounds either by beating our chest or by vocal chants. It only makes sense that we would develop instruments that would either enhance what we already had or replace them entirely. I mean, look at drums, all it is beating a skin. It would also make sense that flutes would be developed, taking our breath and enhancing it. But you may be asking, Connor, where do strings fit in all this? And my answer would be the hunting bow. It is entirely possible that early humans would press one side of the bow against the bottom of their teeth and either strike or pluck said string, using the human mouth as a resonating chamber. Since then, humans have created a million different ways to play music with a string, the most notable being a guitar or violin or even the piano. Humans have also created different stringed instruments depending on how you play them. For example, to play a harp it needs to be plucked, to play a violin it needs to be bowed, and to play a harpsichord it needs to be struck. Keeping those three ways in mind, you can imagine how many different instruments can be made from just using one of those techniques. Some instruments use multiple techniques to be able to play them. For example, you can bow a double bass as well as pluck it. But what about the other end of the string, you may be asking? Well, there are two ways, one of which anyone can play. Do nothing to the string. My example being the harp. All you do is pluck it and it makes a note. The other way to play the opposite end of the string is by fretting it like a guitar or violin. And now we can finally get to the physics portion. You guys remember Pythagoras, right? He was the one that developed the theorem that says a squared plus b squared equals c squared, or that triangle thing that every high school student hates. Well, he also developed the Pythagorean interval, which basically states that intervals can be looked at as ratios. Using these ratios, we can find out any relative note with some math, but the math is very complicated and I do not understand any of it. A couple more things that you should know is that all stringed instruments have a scale length, or how much the string will vibrate. For example, a ukulele has a scale length of 3.5 inches, while the scale length of guitar is 25 inches. But this is where the fun begins. The ukulele note E and the guitar note E are the exact same pitch. Thickness of the string used is also a factor in stringed instruments. The thicker the string, the lower the note, and vice versa. Now referring back to Pythagoras. We can take the scale length of a guitar and scale the fretboard to any size we want, as long as the ratio between the frets is constant across the fretboard. And since the frets were placed there by Pythagoras' ratio, every note should be on pitch according to the original template. Now let's talk about the build of string instruments. Most string instruments are made out of some type of wood, whether it be thick, thin, or tonal. And yes, there is a debate on different woods sounding better, but that's a whole other topic for another day. For now, let's talk about acoustic string instruments. Mainly made from plywood, the thin wood makes it easier for vibrations to travel into the body and to resonate, making the strings louder and more audible. You see this in guitars and violins. The thing that determines the shape is how it is played. For example, the reason violins have a waist is because the low and high strings wouldn't be playable by themselves if a body was there. Now, what about solid wood instruments? How do those work? Well, it's quite simple. Magnetism. Everyone knows that a magnet has its own magnetic field. Well, if you spin thin copper wire around a magnet and attach both ends to an audio jack, metal entering the magnetic field can be heard. This is why electric guitars have metal wires as opposed to nylon or plastic strings. The only downside to this method, what people in the guitar community call a single coil pickup, is that you can hear the hum of electrons flowing through the pickup. That's where humbuckers come in. Despite the name, humbuckers don't hum. They work by having another magnet with more copper wire coiled around it to counteract the hum. A negative plus a negative equals a positive. The only catch is that the second coil needs to have the exact same number of turns on the magnet as the first one does. It also needs to be the exact mirror image of the first pickup in order to counteract the hum. If all is correct, the only thing that should be heard is the clean sound of the string. This method of putting pickups in other stringed instruments is very common. Electric violins are becoming more and more popular every day. I'm recording. Are you ready for clap sync? The last method of amplifying a string is called a piezo pickup. Basically, a piezo pickup is two pieces of metal with a piece of porcelain in between. When vibrations interact with a pickup, the two metal pieces rub up against the porcelain ever so slightly that it creates a small amount of electricity. That electricity can be heard when amplified. This method is usually used when the owner of an acoustic instrument wants to amplify their instrument without a microphone. In conclusion, stringed instruments are extremely complicated precision instruments advanced over many millennia. Cool. And that's it. I don't have to do it anymore. Bye.